Alright, no more fucking wimping out and laying in the bed watching stupid videos. I gotta get better the same way I got sick, slowly. I can't just grind out 6 hours to make up for the studying the past 2 days, because one day I was just tired, went to bed super early, 8 o'clock p.m. Ridiculous. Don't know, I just needed to catch up on sleep, I guess. Body felt like it. Next day, kickball, won, champions. Fucking had to go to bed. And now today, should have done more, but whatever. Half an hour earlier, another hour and a half now. Make up for 66% of it. We'll see. All right. So the point earlier, we were checking pushback and pop back. Pushback to push something on and then the issue here was if we had used direct initialization, well, it needs a type if we're not going to actually give it an initializer. It needs to know what type to generate 3 elements for. Excuse me. Oh wait, what the fuck am I doing? Zero, zero, okay. And the point is that we can now do, if we do this, and then we do, oh duh, this needs to be fucking const, what am I doing? Oops. I don't like this version sucks. Let's use the Pokemon music. It should be good. What the fuck is happening? Why isn't it playing? Wow, that's a good choice. Okay. 0033. Why? Because we've given it 3 elements, which means that it was initialized with size 3 and length 3, because it actually gets 3 elements. But apparently, we could have this guy like this. Okay, 1, this probably isn't good. Oh, well, I guess it doesn't have any elements, so no issue. There's nothing. Okay. But if we do my stack.reserve 56, fuck it. Uh-oh. Oh. Nice. It doesn't have any length, so it actually says, here are all the possible elements you could have, but you have no elements right now. Nothing. Your length is 0. There's nothing you can currently, well, I mean, you could add data, but there's nothing you can currently assign to. There's no index that you can do. Well, oh, fucking gnat. There's a gnat. I left chicken in the trash just a day too long. Oh. Uh-oh. Yeah, see? So it's out of range. Like right now, if we... I mean, yeah, again, yeah, it's fine. The length is still 0. There's nothing that we can actually index. So even though the capacity is huge, this big chunk of memory that we're looking at, big, it's 56 bytes. It's nothing, but it's something. For this one standard vector, we still can't put elements anywhere because there's no actual valid section of it. We just have a potential section. Cool. So we can use reserve to do that. And push back and pop back to add and remove off the top. Which means we could have the capacity and we could say my stack dot push back. We'll push back 5. So is it just one element 5 and then capacity is still the same? Yeah, length 1 now. So we've pushed one thing onto the stack. So this is your stack capacity. So the analogy earlier actually makes sense. It's kind of an annoying analogy. I like just having a stack of plates, pushing things on and then popping them off. But it doesn't say anything about the maximum amount of plates you could possibly have. In our case, we have like these transparent plates, right? And those are each slots where we could put elements. But if we don't have any, if we have a length of 0, we can't do anything. But when we actually do have a length, which we set via size, then we can put them in. So if we didn't do this pushback, I can't do my stack 0 equals 3 is assigned 3. This won't work because our length is 0. We don't have anything valid. There are no valid elements which we can assign value to. Oh, okay, here we go. This is where we were. So the point here is that we've created one with capacity and length 3 because we've said, hey, create 3 elements that are valid, not reserve memory for 3 elements. We've said, don't create a potential stack of 3. We've said, create a potential stack of 3 and fill it with 3. Because using direct initialization like this says, allocate memory for 3 elements and create 3 value initialized or default initialized elements to fill them. Oh, we weren't actually looping. Perfect. Good time. Oh, that's a good one too. Yep, starts with capacity, but also the length. That's the issue here. And we push things on top and pop things off of the length. And the length is the number of actual used capacity pieces. I don't know how I haven't studied the Pokemon music before. This is the best idea ever. Yep, because those are the initial elements. The length measures the amount of actual elements in your standard vector, while the capacity is the amount that you could have before reallocation is required. It's the maximum size. Well, it's the maximum. Well, it's the it's the maximum size you could have. Meaning length. Yeah, when we're intending to access the elements at the length that we have set. Yeah, if we're going to be using subscripts, it means that we have this list of potential elements, not elements, but potential elements. If we're going to be using subscripts, and we fill this guy with however many pieces we need. Like, let's say in a card game, over a series of turns, you increase how many cards you have. But by default, we make it so that your hand is automatically 5 cards. It's just that value gets assigned to these over the turns. So it's technically you have a king and then 0, 0, 0, 0, or a king and then blank, 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 blank. Let's say it's an enum. So there's blank, king, queen, jack, joker, ace. So you have king, blank, 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 or king, blank, 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 right? That's fine because we can evaluate these and see, hey, is it actually blank? Okay, cool. Don't do anything with it. Whatever. But if we're using it as a stack, we have to use the other elements as is. Excuse me. And with a stack, it's problematic. And with a stack, those blank elements become a problem because we can only push things on and pop things off of the stack. We would have to pop those elements to remove them. Which, I mean, I think we could do, right? Sure, and then we'll do well, we don't actually want to iterate it. We just want to do it. Yeah, sure. What? I'm not sure why that. Oh, because we're making him const. Okay. And not to mention this wasn't a reference either. That was stupid. It needed a parameter when it was pushed, so that's why there was an issue there. Yeah, length is 5, and we can pop these guys off to remove them. And really, that's what should be going on. Make a const expression so we can do this at compile time. Okay, value initialized is 0, 0. Noted. Yep, so we say, okay, this guy's 0, 0. We're going to print stack, stack. We're going to get 0, 0. Reserve 6. Length 0, capacity 6. And then length 1, capacity 6. And then length 2, capacity 6. Length 3, capacity 6. and then the top is 3 because back will get the top element. So it's 1, 2, 3, but capacity 6, and then pop, pop, pop. So then it goes length 2, capacity 6, length 1, capacity 6, length 0, capacity 6. Yep. And if we're talking values, nothing, 1, 2, 3, and then 2, 1, nothing. Yeah. 1, 2, and 3. 2, 1, 0. Yeah. Yeah, because we're saying, hey, take up this much memory in advance, instead of saying only take up this much and you have to reallocate to get new elements. Instead, take up this much and I can just fill you with elements over time. No reallocator needed. Yeah, if we resize it, we can have a blank standard vector, capacity 6, length 0. But if I resize it to 3, it's going to generate those 3 blank elements. But if we reserve, can reserve dynamically change? I guess it has to, right? If it can update from 0 to 6, why can't it update from 6 to 0? Oh! Okay. What if we do resize to 3? Oh wait, yeah, because reserving, oh, it would have to be shrink to fit, but it doesn't even have that many elements. I'm not sure if there's a way to take it from, to say reserve this much, but then deallocate to here specifically, even though you don't have elements that are exact there. We would need 3 elements in there and then shrink to fit. Yeah, if we want to use indexing so that we can actually access that place, we do resize. But we do reserve if we're not actually going to use it, when we just do pushing on and popping off. Push back versus in place back. If the object already exists, it's equivalent. Oh, but if we're doing a temporary, okay, totally not what I was expecting. Live stream string view vector. Okay. Oh. Oh, like a temporary object then? So if we say this guy is, did I loop this thing? I fucking did. Cole versus who I wanted earlier. Yeah. Luckily, still at it. Nice. Okay. And if we wanted, we could print the length and capacity here. 0, 0. Well, it's 0, 0 here. And then here it'd be 1, 1. Right? We'll just verify. Cool. Expected. Oh, fuck me. Not pushback. It's in place back. Same shit. Does it use no, it's not move semantics. I'm not sure. Well, it could be though, because it's temporary. It's movable, so maybe. Oh. So if we create a class as a two private data members, a string and an integer, and then a constructor to create it with a standard string view. Well, to initialize its variables with a string view and an int. But then we also have an explicit constructor if only giving it an integer and not a standard string. Then value initializes the standard string. Mm. And then in this case, it is of that type because it's a string and an integer. So instead of taking it and then copying it in there when it could be expensive, we can do in place. But just put the expensive guy straight in there. Pushback will not use explicit constructors. In place back will. Okay. So if we do pushback 2, explicit, it won't work, but in place back will. Okay. Makes sense, yeah. Oh shit, I just saw that. Yeah, the pushback in this case, we're passing it one object here. Well, no, I guess not, huh? Well, oh, because we're doing pushback with an entire thing, with an entire element. Yeah, that makes sense, huh? Because if standard vector is of type foo, then what we have to push back is a foo. So we're doing an implicit constructor call. And then same thing here, but with those arguments as one thing. Hmm. Yeah, it shit just loops forever. Gotcha. Instead of copying, or instead of creating one object and then copying it into this other spot, we just create it where it's needed. Okay. A feature called perfect forwarding. Creating it where it's needed instead of creating it and then moving it or copying it where it's needed. Hmm. Instead of creating and copying, it's just boom, straight assignment. Creating it there. Yeah, it makes sense. Yeah, because if you fuck up on the arguments on a default call with pushback, it won't call the explicit. It'll only call the default. But if you call an explicit, where you're supposed to be more type sensitive than normal and more cautious, you don't want to accidentally call that. Because if you're calling it explicit, you're probably wanting to disallow that conversion anyway. Well, that's why you would do it, to disallow the conversion. Explicit or to avoid copying. Okay. Okay, we have a list of scores. I'm going to say while true. Enter a score. Handle valid input. If it's less than 1, oh, or -1 to finish. Gotcha. And each time it's going to push back to increase the length and add another. Okay. Okay. I'm dead tired. I gotta go to sleep. Sorry.